Okay, so today we have a power bank on both ends of the microphone, so we should not run out of audio. And we've just got some feedback on the screen. We should even be able to do screen capture today, so we're in for a treat. People are showing up in the chat. Hello. So, this box, as well as this box, belong to a 500 horsepower marine diesel engine. And one would assume a marine diesel engine does not require a lot of electronics, but this one does, because this is the entirety of the instrument cluster. And what happens is, when you turn all the tech on, this will not display anything. The backlight will go on, but it won't show anything on the screens. However, the segments will go on, it'll go beep, it'll blank out this 7-segment display down here, so we know the processor is fine on these. And I have been on the site and troubleshooted the entire system, and it seems we have a CANBUS issue with this device, and it's had a wiring loom failure, almost a wiring loom fire, which caused one of the CANBUS 120 ohm termination resistors in the loom to basically destroy itself. So we know we've had a serious CANBUS problem on this system, and it's caused a failure. So I have actually probed around on the CANBUS while this was running, and when we plug the display in, one of the lines will get stuck low. Unplug the display, the CANBUS looks as you would expect it to. So I have the display, which is the issue, and the other end, the box, which is like the CANBUS hub or something, with me here. And what we're going to be aiming to do is find the CANBUS chips on these and order replacements later, if we can. So this one's going to be a breeze. That's why I set up a screen capture, because well, this is almost looking burnt. We'll have a look on the microscope, because we're just going to be grinding a bunch of data sheets. This is not going to be the most interesting stream, I don't think, except once we get into this display, we're going to have a bunch of fun, as you will see. But for the time being, I just want to see this. Why is this? There we go. No? Why? What am I doing wrong? There we go. So let's just do that, and we're going to go on a hunt for a CANBUS driver chip. Now we can actually skip the microscope for the time being, because I think I remember which of the pins were the actual CANBUS driver, and I think it's these two guys here, pins 2 and 3, are CANBUS low and CANBUS high lines. So if those go, they go over there, there are 2 VS, which pop on over to, I believe, this small 8-pin chip. That looks, yeah. So this 8-pin chip here is probably the CANBUS driver on this box. Now the reason I know where those 2 pins are, the reason I knew where to look there, is because that's actually documented in the manual for the entire engine system, which this came from. The engine this belongs to, for those curious, is an Iveco, what's it called? Cursor 8, yeah, an Iveco Cursor 8. So it's, I'm not sure if it's a straight 6 or straight 8, 500 horsepower marine diesel. It's rather large. Very large, actually. So let's see if that is indeed our CANBUS drive chip there. That's got some text. what's that say? The chat is asking, marine diesel, like for a boat? Yes. Boats are where you use marine diesels, hence why you call them marine diesels. Or you generally call like a stationary industrial diesel and marine diesel as well. Low revving diesels, essentially. So I'm not sure if you guys can see that at all, but this chip is an A82C251 and some other stuff. A82C251. So A82C something something. Now let's use a better web browser. A82C251. Thank you, Google. What are you? CAN interface IC. Okay, so that seems to be our CAN interface. Restart later. The PCA82C251 is the interface between a CAN protocol controller and the physical bus. The device provides differential transmit capability to the bus and differential receive capability to the CAN controller. So, that's one of the chips we're going to try and order. Excellent, that's the easy part of the job done. Now we know, now we get to do the fun thing. And I'm going to show you why we're going to be having a bunch of... not fun, that's the wrong thing, oh god. Someone's asking, so what was with the OD instrument cluster? Can't watch it, FFS. Yeah, I'm going to publish that later tonight. It should be done processing by now. So that's going to be going up soon, like the recording of the stream, unless YouTube's bugged it up. I just fixed a bunch of solder joints and met with a customer today. It still didn't work. Well, all the gauges and backlighting worked, which I think is a step up, but the display did not work, which I basically expected. Someone says, sound is awful. I don't know. My sound sounds fine to me, but we do have a heating fan running in the background. And I have a bit of feedback going on, just so that I might notice if my sound goes out, because as you might know, if you're a regular viewer, our sound always goes out. So I'm prepared this time around. And is that the same guy complaining about... Oh yeah, that's the same guy complaining about the Audi thing. Yeah, the Audi stream is going to come up at some point. And yeah man, don't worry, I am going to publish the Audi live stream. It's just YouTube needs to process it before I can publish it, or it's just basically falls apart. Anyway, this is the inside of our marine diesel instrument cluster, and it's just a bunch of screens, and that's a problem, because even if we undo a single remaining screw, we're not going to be able to tell much more about this, because on the backside we only have the processor. So that means our CANBUS controller or CANBUS driver IC is stuck under one of these displays. So we are going to have to desolder one of these giant custom LCDs in order to find out where the CANBUS driver IC is, so that we may replace it and return this device to service. And I have no idea where the chip is going to be. So I'm going to have to look between the boards here. You're not going to be able to see anything. I'm sorry, I can't get it on camera properly. But I'm going to see if I can spot an 8-pin surface mount IC between the displays, and if I can spot one, we'll desolder that display, because likely that's our CANBUS driver, since it was an 8-pin chip on the controller. And we do have an 8-pin chip underneath the big one. Of course, it had to be the big one. Of course. I don't think that's... Yeah, we are not going to be able to tell anything about that chip without removing the display. But you can see... yeah, it's... To make matters worse, it seems to be stuck... Yeah, it's right underneath the processor. So we can't even probe out any vias or stuff going to it, because it's just... We don't know anything. We have to remove the display. To those who are just joining us, this is the display for a marine diesel, very big expensive engine, and it has a CANBUS issue, where if you plug this display into the CANBUS system, it'll display nothing and the CANBUS breaks. So we're chasing for a broken CANBUS driver IC, which is going to be somewhere on this board. I think it's right there underneath the big display. So we need to desolder the display, verify that that is our CANBUS driver IC, and then I need to order a new one and get it on. Because a new one of these is probably ridiculously expensive, and the hour counter for the engine is stuck in that chip. So in order not to lie to any future buyers of your engine, we'd have to move this chip over to the new display anyway, which also entails desoldering the big LCD. So I'm just gonna make a small mark on the LCD to make sure we get it on the same way as we took it off. And someone's asking how I diagnosed this. I diagnosed it by running the system and plugging this in, and while probing the CANBUS with an oscilloscope. And when you plug this display unit into the harness connector, the CANBUS stops working. One of the lines is stuck tied low, and the display won't work. So I'm quite sure it's this. Furthermore, the only things on the CANBUS are this controller and this display. And I'm going to replace the CANBUS driver ICs in both. The CANBUS is properly terminated, so it's not an issue with that. It's just that it's broken. It seems to be tied to a logic low or a logic high, whichever way you want to look at it. So I think this might be horribly potted. Yeah, this is horribly potted. So let's just get under the microscope and poke away at some of the potting compound so we don't completely jam our desoldering pump, because that's a bad day. Let's just get in there with a blade. Is it going to work better? Yeah, that's prettier. And I made a nice solder ball there. Off you go. So the rest of this stream for a good while now is just going to be grinding, tearing into potting compound and desoldering this great big display. So for the fans of the desoldering pump, well, this is going to be a treat. For anyone expecting intelligent troubleshooting, it's not going to be. So keep that in mind. I have a real treat coming up next week probably as well. I have a board from an ancient skylift which has been absolutely completely abused over the years. It's been repaired a bunch of times, and we need to go through it a bit. Met up with the owner of that Skylift today and was like, yeah, I don't want to touch this thing. If you want to pay me some money, I can go through it, but I'm not going to warrant anything. You're going to have to pay regardless of what happens. And he was like, okay. So we're going to have a look at that, hopefully on stream. Potting compound is horrible, but very, very important. And you guys, you can barely even see the blade in that camera. Stupid microphone camera. Someone's asking for the part number of this device. Like the part number for the actual display is an Iveco 804-2053. An Iveco 804-2053. Dating from 2006-2007. So it's a 10-year-old, almost 15-year-old engine. It looked in quite good condition actually, like the actual motor. I've seen the owner of this marine diesel has it out of a boat. I think he bought it from like a scrapped boat or something, and he's got it sitting on a pallet in his garage for servicing. And it's a really nice looking motor. It's in very good external condition, so I don't think it's got too many hours on it, and it's certainly been well kept. But the guy works on like luxury yacht type boats, so it's probably been owned by a very, very rich person. Now you can't, I'm not getting rid of all the potting compound on here, because that's just too much work. I'm scratching away most of it just to have, well, not even most of it, just a bit of it, just to get better thermal conductivity onto the solder. Because if I just try to apply the desoldering pump through the potting compound, it's just not going to thermally conduct very well. We get a bunch of burnt potting compound and a non-molten solder joint, and no one wants that. So this is just for thermal conductivity, and just a little bit too. Make it easier to access. So brush all the debris off, and now we can start desoldering this great big thing. Someone says this looks like conformal coating, and yes, that's exactly what it is. I don't know why I'm calling it potting compound. It's conformal coating. Alright, time for some sake. Oh god, that's gone horribly wrong. There was no sake. There's probably conformal coating on the other side of the board as well, which is going to make it very difficult to evacuate the holes. Oh god. This is going to be painful. Yeah, I don't think that's evacuating the holes properly. Oh yeah, it actually is. It actually is. I think. Oh yeah, it is evacuating the holes. Excellent. Thank goodness there was just not enough noise being produced for me to be happy, because the hole is tiny. I'm going to see if I can swap to a smaller tip on the desoldering pump, because the one I have on is a bit bigger than it needs to be. And you want to have, on these pumps, you want to have as small a desoldering tip as possible. My chair is cancer. Someone's asking what we're doing, and we are in the process of finding out what the CANBUS drive chip on this device is. The device being a super expensive display for a big marine motor engine, and we need to desolder we need to solder the big LCD panel here in order to find out what chip is hiding underneath. So we're basically just going to be desoldering pins for a good long time. The reason for this is that I have been to the site where the big engine is currently located. I brought a scope and I probed the CAN bus, and I noticed as soon as you plug the display in, the CAN bus stops working and the display doesn't work. So we obviously have an issue where the CANBUS driver on the display isn't doing too good. And the cause of the failure is a wiring loom failure in the engine room, where basically all the wiring had melted together and there was a bunch of shorts left and right. I think the CANBUS has probably gotten like B battery positive into it, which has set fire to all the termination resistors. So it seems that the CANBUS drive chip in the display got the worst of it, because it seems to be shorted to a logic low. Just have to, there's a brand new tip, so we have to tin it up properly so it's not gonna just oxidize and turn into crap. So much smoke. Okay, well, let's get back to work. Give you guys a slightly better view. There we go. So yeah, now we're just going to be desoldering this. Oh, that sounds so horrible. I'm just going to have to. You usually don't want there to be like the strained vacuum pump sound. You want this pump to run smoothly and lightly with plenty of flow, because when it's making the like strained vacuum pump sound, it means there's a lot of resistance, which could mean that you're not actually clearing the hole properly, which is bad. Someone suggested using solder braid for this. That does not work on plated through boards. Solder wick works on capillary force, meaning that if you have something with great capillary force, like a through hole, a plated through hole, the capillary force holding the solder to the joint is often greater than the capillary force drawing the solder into the solder braid. So you can braid this all you want, it's just not going to do anything. The solder is just going to stick in the hole. On single layer boards that are not plated through, solder braid works fine. I'm surprised we haven't clogged up the sucky yet. Someone says, the pump sounds like a very unhappy cow. Yeah, it really does. This is a bit like the sound of a slaughterhouse when someone's just going with the big spike gun to the forehead of a cow. Donk, donk, donk. I just fall dead, turn into beef. That's gruesome. I can't get the image out of my head now. And all the little cowlets are gonna be calves. They're called a calf. A young cow is a calf. They're gonna be out of a mummy or daddy, because their mummy or daddy got turned into a hamburger. This was actually working. Ah, yeah. I think the holes are actually getting evacuated. I'm surprised to see that actually. It's very good that the holes are getting evacuated, but yeah, usually when the pump makes that noise, they're not. Someone's saying something about measuring the CANBUS. I have measured the CANBUS while this thing is operating. The CANBUS termination resistance is 60 ohms, as it should be, because there are 2 nodes on it, but it doesn't work when you power it up. Trust me when I tell you, the CANBUS driver in this thing is bad. Okay, that's all of the pins for the LCD panel. So now we want to go through and poke all of them, every single one, with the tweezers to make sure that they're actually released from the board, because we really don't want to repeat through plating. So I'm just going to go through and poke them, make sure that every single one moves freely. This guy does not move freely, so we need to put some fresh tin on that and suck it again. Kill another cow. Is that going to be alright? Come on. Nope. So that one's probably tied to a ground layer on the top side of the board. So we want to put on some solder heater for a decent amount of time and just suck it. Making sure we allow time for the solder to actually heat up through the entire through hole. I can't got the pad with me. And the pin still is not loose. Oh, that was a bit of a failure. Spare pad can go to the side, we don't need you right now. What's keeping this thing? I don't think anything actually is holding this thing really. It's this top pin here. there we go. Just applied a bit of force to it and it'll let go. So that's all the pins on that side loose. That means I need to be really careful to hold the LCD panel in place when we flip this, else it's going to go flying. So now we're just going to go through all the pins on the other side. That one's not loose. So 2 in the end there are not loose. Good, good. This one comes. Yeah, good. I got wood. Good, 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 good. Good, good, good. Good. Good, 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 good. Good. So I'll just lift the VLCD slightly, which is not a huge problem. This one last guy is stuck on there, so we'll put some tin on, desolder it a bit more thoroughly. Hopefully it's gonna come. Yeah, that took nothing, it's actually mobile now. Ah, there we go. So now we should be able to basically just lift this board, leaving the LCD on the table. Ta-da! Like magic. So now we have access to the underside. Let's hope we have a CANBUS driver around here somewhere. Let's have a look at what our chips are. So that's an ADM123. That does not look like a CANBUS driver to me. Let's Google that. ADM123. ADM123, just the pin I saw on that. Did not look. What are you? Pin compatible with Max 1232. The ADM12328 is a microprocessor monitoring circuit that monitors microprocessor supply voltage. It can also detect if a microprocessor has locked up, so this is not what we want. Which is a shame. The chase moves forward. That 8-pin chip was what I thought was going to be our driver, because it was an 8-pin chip in the other end. On the we have this thing, which is at the other end of the system. It had an 8-pin chip for the CANBUS driver. But we do have some stuff buried under these foam pads, so we'll just poke those off and see if we can find something there. Those are not going to come cleanly at all. Oh man. I kind of just want to poke around. I know which pins the CANBUS signals are on, if I remember which without fetching my notes. One of the pins of the corner is CANBUS, and none of the pins of the corner are connected on that side of the board, so we're not going to find that out. So we have an 8 or 14 pin chip there. That could also be a CANBUS driver. foamy stuff is not being nice to us. You go over there. I said go over there. So let's give that guy a scratch. See what he is. I'm seeing an ST logo, and I think we have an ST normal logic gate on the other side, so that's not promising. If this is just a logic gate, I'm not going to be happy. Right, you guys are completely out of focus. There we go. What are you? 74HC14. So that does not at all sound like a CANBUS driver. It's a 74,000 series logic. I'm just going to Google that to be sure. 74HC14. What are you? Hex inverting Schmidt trigger. That doesn't sound like what we want. Oh, how annoying. So let's just see what the big chips are. The giant chip in the middle there is going to be the LCD driver. We don't care about that. This is an SJA one phase and T something. The SGA one phase is a standalone controller for the controller. Okay. What are you? Standalone CAN controller, bingo. That's the broken guy. So this thing, I really hope this thing is not like programmable. Oh god, it's got a bunch of registers. If this thing's got memory and shit built into it, I don't want to live anymore. I'm just looking for anything which might suggest this thing is programmed. Oh, that's a nice big block diagram. I'm not seeing anything relating to programming it. This is the failed chip, so we're gonna have to replace it. Let's check the chat, see if the chat knows anything about it. Everyone's saying it's not programmable, so I'm just gonna take your word for it. So that's what we want now. Let's just go. Let's just go to Mesa and go through the horrible cancer selection thing which you cannot get through. Mouse, why have you not fixed this? You have to click that like 5 times for it to work. Right, let's find the specific number on this thing with a microscope, which is not visible to you guys right now. It seems to just say SJA 1000T. SJA 1000T. SJA 1000T. Hey, there's something there. Is it stocked, non-stocked? Hey, we have something. So what's the difference between an SJA 1000T/N1, 112 and an SJA 1000T/N1, 118? One is bulk packaging, the other is cut tape, okay. Cost the same. Is the data sheet going to tell us anything? Where's the ordering information of this? So if you're out for like interesting electronicsy stuff, we're pretty much done soldering and working on the circuit right now. We're just going to be grinding data sheets, trying to figure out. Can we just Control F118? So we had 2 hits for 118. Ordering information page. Ah. Okay, that tells us SA28. Okay, so well, what the hell does the final thing mean? Well, I'm just going to assume that as long as it's for SJA 1000T, we're going to be good, and it's stocked on Mesa, so I'm just going to throw one of these on my next Mesa order, and we're pretty much going to be done. So that was reasonably easy. Let's just mount, just vaguely mount the LCD back on there so we don't break it more than we need to. And then we're pretty much done here for tonight, and I'm gonna call it. Whoa, this thing is slippery. Someone said mark out the orientation. I already did. This thing is a rather cool backlight solution where they just have this loose piece of plastic and a bunch of really weird LEDs. Like these are through-hole LEDs which shoot light in there. Oh god, we have sticky side against sticky side. This is not going to be pretty. It was pretty. Okay. That's a really novel solution. I like that. They're just using the LEDs to hold the plastic sheeting in place. So I'm not going to solder the LCD. Hey, we have. We've turned it on. Can we display things on this? Come on. No, it doesn't want to go. There we go. Let's just put some tape on that to hold it in place while we wait for the arrival of our new CANBUS controller IC. Someone asks, where was the board manufactured? I have no idea actually. It's labeled MC Electronics. So I'm assuming that's the manufacturer. I don't know where they actually make stuff. Never heard of them before. Alright, that's the LCD taped in place, that's going to go anywhere. Let's make sure it's not going to go anywhere. No, that's fine. And yeah, that's it for the time being. I'm going to actually put this in the case to protect it. Stop it getting dirty. We don't want no dirty electronics around here. We're clean swamp. And did I save? Yeah, I'll probably save the number for this chip as well somewhere around the data sheets. Yeah. So let's check on the chat and sign off because we're done. It's Friday. TBBW says, and through the magic of streaming and a cutscene, here are the parts from Mauser. Sadly, we can't just teleport parts from Mauser in here. We have not got such a good deal with DHL yet. But yeah, we're done. Have a good night. Make sure you enjoy yourself. Bye.